What if the safest place on Earth was also the reason you were most likely to be found? Imagine a mountain in northern Iran. From above, it looks like almost nothing. Rock dust, a few roads, perhaps some buildings scattered across the landscape. But underneath that mountain is a different world. Tunnels, concrete, power ventilation, precision machinery. And somewhere inside, a facility built around one simple idea. If you cannot protect something in the open, bury it so deeply that no one can reach it. For years, that idea seemed to work until the mountain itself became the target. This is the story of Fordow and the strange strategic contest behind it, because the most important question was never simply whether America had a bomb powerful. The real question was much more difficult. Could an underground facility be made truly invisible? And if it could not, what happens when an enemy spends years studying every weakness that the mountain is forced to reveal? The mountain was not the only hero of this story. The true hero object is the Fay Buffet, massive ordnance penetrator Fay, a weapon designed around a terrifying problem. How do you attack something that was deliberately built to survive an attack? The answer begins with a contradiction. The deeper Iran buried its nuclear infrastructure, the more difficult it became to destroy. But the deeper it went, the more dependent it became on the surface. Every underground facility needs air. It needs electricity. It needs roads. It needs workers. It needs machinery to enter and waste material to leave. A mountain can hide a facility, but it cannot make the facility independent from the world above it. That small fact became strategically important. Because finding a buried target is not simply about seeing the target. It is about understanding the system that keeps the target alive. And that is where the visible story begins to hide a deeper one. Iran's nuclear program has roots that stretch back decades. Under the Shah, Iran's nuclear ambitions were initially developed with Western support and framed around peaceful energy. Then came the Fay Revolution war with Iraq sanctions, isolation, and a growing belief inside Iran that foreign powers were determined to limit the country's strategic independence. By the late phase and early phase, Iran's nuclear activities had become a growing source of international concern. The debate centered on a fundamental uncertainty. Was Iran building a peaceful nuclear capability, or was it developing the infrastructure that could eventually support a nuclear weapon? That distinction became increasingly difficult to ignore. Then satellite imagery began revealing something unusual. Near QAM construction patterns suggested that Iran was developing a facility unlike a conventional industrial plant. Roads, excavation, construction activity, and eventually the outline of something built into the earth. In Fay, the United States, Britain, and France publicly revealed the existence of the Fordow enrichment facility. And suddenly, the mountain had a name. Fordow, the facility, was smaller than Natanz, but strategically, it was something different. It was hardened, it was concealed, and it was buried deep enough to create a problem that ordinary air power could not easily solve. The message was obvious. If an adversary controls the sky, go underneath it. This is one of the oldest instincts in military history. Castles went behind walls. Command centers went underground. Missile systems disappeared into silos. Nations learned that depth and time in warfare can be almost as valuable as armor. But here is the problem. Depth does not eliminate vulnerability. It changes the kind of vulnerability you have. A bunker can survive a direct attack, but it still needs an entrance. It still needs ventilation. It still needs electricity. And once those connections are identified, the fortress begins to reveal its shape. That is why Fordow became more than a nuclear facility. It became an intelligence problem. And intelligence problems are rarely solved in a single day. Imagine a satellite image covering the same mountain year after year. Analysts compare one photograph with another. A road changes. A new structure appears. A pile of excavated rock grows. A vent becomes visible. A construction pattern reveals that something is happening below. None of these clues proves exactly what lies underground, but together, they begin to form a picture. The part most people miss is that modern bunker warfare often begins long before the first bomb is loaded onto an aircraft. The first weapon is information. The second is patience. And only then comes the explosive. For years, analysts studied the physical environment around Fordo. The objective was not necessarily to see through hundreds of feet of rock. It was to understand how the facility functioned. Where did people enter? Where did equipment move? How was the site powered? Where did air circulate? What structures were connected? What parts of the mountain could be used to reach the parts that mattered? This is where the G-Buffet enters the story. The weapon is enormous, more than 20 feet long, roughly 30,000 pounds, and built for a very specific mission. Not to create the largest explosion possible, but to survive the impact, penetrate the earth, reach deep, and detonate where the explosion can cause maximum structural damage. That difference is critical. A normal bomb attacks a target from the outside. A bunker penetrator tries to attack the target from within the structure protecting it. The mountain is no longer simply the obstacle. The weapon is designed to turn the obstacle into part of the attack. But technology alone was not enough. The weapon needed a delivery system, and that meant the B-phase spirit. A stealth bomber designed decades ago for a Cold War that never ended in quite the way its designers expected. The B-phase could carry the G-Buffet internally, preserving its stealth characteristics. But the aircraft was only one component. A mission of this scale required intelligence, refueling, electronic support, route planning, fighter protection, command and control, and political authorization. The weapon might take seconds to fall. The system required years to build. And this changes everything, because the real American advantage was never simply the 30,000-pound bomb. It was the ability to connect intelligence, engineering, stealth, logistics, and military power into one The mountain was facing more than an aircraft. It was facing an entire national security architecture. But Iran had an architecture of its own. The facility was designed around the assumption that conventional military power could be denied access by depth. And for a time, that assumption was reasonable. Older bunker, busting weapons could penetrate hardened structures. But Fordo represented a different challenge. The target was not merely reinforced concrete. It was rock. Layer after layer of rock. The problem was not making an explosion bigger. The problem was getting the weapon deep enough to make the explosion matter. That distinction explains why the G-Buffet became so important. And it also explains why the mountain became such a dangerous symbol. Because the question was no longer whether America could destroy a building. The question was whether modern technology could defeat geography itself. And that is where the visible conflict begins to break apart. Everyone could see the mountain. Everyone could see the bomb. Everyone could see the aircraft. But almost nobody could see the real battlefield. It existed beneath the surface inside intelligence databases, satellite archives, engineering simulations, political calculations, and the clock. Because while the world debated whether Fordo could be attacked, Iran's nuclear program continued to evolve. The Faye nuclear agreement placed restrictions on parts of Iran's nuclear activities. But the agreement later became a political battleground. The United States withdrew from the deal in Faye. Iran subsequently expanded aspects of its nuclear program and increased enrichment levels. By the mid-phase, uranium enriched to around Fe% had become a major international concern. That material was not itself a nuclear weapon, but it represented a dramatically shorter technical distance from weapons. Great enrichment. And suddenly, the mountain was no longer just a bunker, it was a clock. Every month mattered, every centrifuge mattered, every kilogram mattered. Every decision created a new calculation. The United States had to consider the possibility that a military strike might delay Iran's nuclear ambitions, but it also had to consider what would happen afterward. Iran could retaliate, regional allies could become targets, energy markets could react, oil prices could rise, shipping routes could be threatened, and a conflict involving Iran could spread across the Middle East. This is the contradiction at the center of the entire story. The stronger the military option became, the greater the political consequences of using it. And the more dangerous the nuclear program appeared, the harder it became to ignore the military option. The mountain was therefore doing something unexpected. It was not only protecting a facility, it was forcing every decision maker outside it to confront the cost of attacking it. That is the strategic importance of Fordo. It transformed military capability into political uncertainty, but then the logic changed, because if the mountain could not be ignored, the question became, could it be penetrated? And if it could be penetrated, would destroying the facility actually solve the problem? That is where the story moves beyond the bomb. Because the deepest battlefield was never the mountain. It was the system behind it. And once that becomes clear, the entire meaning of the strike changes. Everyone thinks this battle is about a bomb and a mountain, but the real battle is about something much harder to destroy, a system that can rebuild. That is the transformation, because once the first weapon hits the ground, the question changes. Before the strike, the question is, can you reach the target? After the strike, the question becomes, what remains, and more importantly, what happens next? Reports surrounding the American operation described a highly coordinated mission. Stealth bombers, refueling aircraft, intelligence assets, supporting aircraft cruise missiles, deception, timing. The objective was not simply to drop a bomb, it was to create a temporary window in which the entire system could function faster than the target could respond. That is modern warfare. The aircraft is visible. The logistics are mostly invisible. The weapon is dramatic. The intelligence is not. But without the invisible system, the visible weapon may never reach the target. And that is why the GBU represents something much larger than its size. It represents the convergence of several technologies: precision guidance, penetration engineering, stealth, satellite surveillance, electronic warfare, aerial refueling, global logistics, and intelligence analysis. Each capability solves a different problem together. They create an entirely different kind of military power. The mountain was built to stop a bomb. The United States built a system designed to solve the mountain. But here is the problem. Even the most sophisticated attack cannot guarantee perfect knowledge, especially underground. When a facility is buried beneath rock, the attacker may know where the entrances are. It may know the approximate location of major chambers. It may understand the ventilation network, but it cannot see everything. And that uncertainty becomes critical after the strike. Early assessments can be dramatic. Images may show disturbed earth, collapsed entrances, cratered ridge lines, destroyed structures, but satellite imagery can only tell you what happened on the surface. It cannot easily reveal whether a chamber hundreds of feet underground survived. It cannot tell you whether every centrifuge was destroyed. And it cannot tell you whether nuclear material was moved before the attack. This is why battle damage assessment becomes its own intelligence war. The first strike ends. The second battle begins. Analysts compare satellite images. Signals intelligence is examined. Human intelligence becomes more important. Officials debate competing assessments, and the target itself becomes increasingly difficult to understand. A military operation can be successful while its strategic outcome remains uncertain. A facility can be severely damaged. A nuclear program can be delayed. And yet the underlying knowledge can survive. Engineers can survive, scientists can survive, supply chains can be rebuilt, equipment can be replaced, and knowledge cannot be destroyed by collapsing a tunnel. The lesson here is uncomfortable. The most important thing inside a nuclear program may not be the building. It may be the human network that knows how to build the next one. That is why the destruction of infrastructure and the destruction of capability are not always the same thing. And this is where the Fordo story becomes a lesson about modern warfare itself. The visible battlefield is the crater. The invisible battlefield is the recovery timeline. How quickly can the target rebuild? How much expertise remains? How much equipment survived? How much material was moved? How much political pressure can the government absorb? And perhaps most importantly, what did the target learn? Because every successful attack teaches the defender something. A bunker that is penetrated becomes a blueprint for the next bunker. A ventilation shaft that becomes vulnerable may be redesigned. A facility that is easy to locate may be dispersed. A centralized program may become decentralized. A visible target may disappear underground. The attacker adapts. The defender adapts. And the cycle begins again. This is the invisible battlefield principle. The real weapon is not always the explosion. Sometimes the real weapon is the uncertainty created by the possibility of the explosion. If a government believes that any facility can eventually be found and attacked, it must spend more money protecting it, more resources on secrecy, more resources on deception, more resources on redundancy, more resources on underground construction. Military power creates economic pressure even when no weapon is fired, and that pressure extends far beyond the mountain. Iran's nuclear program is connected to sanctions. Sanctions are connected to energy markets. Energy markets are connected to global inflation. Global inflation affects governments thousands of miles away, and those governments then make decisions about alliances, military spending, and diplomacy. This is why modern conflict cannot be understood by looking only at aircraft and bombs. The battlefield extends into financial systems, industrial capacity, energy infrastructure, supply chains, political legitimacy, and public psychology. A single strike can therefore create effects that travel far beyond the target. But the opposite is also true. A military strike can destroy infrastructure without solving the political problem that created the conflict. That is the deeper contradiction. A bomb can reach a mountain, but can it reach a decision? Can it convince a government to abandon an ambition? Can it create a political settlement? Can it remove the security fears that caused the program to exist in the first place? These are different problems. And military technology is far better at solving the first than the others. Strategically, this changes the entire interpretation of the operation. The purpose of a strike may not be to permanently eliminate a capability. It may be to buy time. Time for diplomacy, time for inspections, time for sanctions, time for negotiations, or, depending on how the target responds, time for the next escalation. That is why the word fait delay. Fait can be more important than the word fait destruction. Fait delay can be strategically valuable, but it is not the same as a permanent solution. And that creates a dangerous feedback loop. If a government believes its underground facilities are vulnerable, it may respond by building deeper. If deeper facilities become vulnerable, it may disperse them. If dispersion makes them harder to monitor, it may accelerate secrecy. And if secrecy increases suspicion, military pressure may increase again. The cycle becomes self-reinforcing. This is the paradox of bunker warfare. The better you become at destroying bunkers, the more attractive it may become for some governments to build something even harder to destroy. And eventually, the logic can reach its most dangerous conclusion. If conventional forces can always threaten your strategic infrastructure, perhaps you need a capability that conventional forces cannot easily threaten. That is where nuclear deterrence enters the picture. And that is why the consequences of an attack can extend beyond the target itself. The attack may demonstrate American military reach, but it may also influence the strategic thinking of every government watching. North Korea watches, China watches, Russia watches, other states watch. They study the same question: if the United States can penetrate one of the world's deepest military facilities, what does that mean for their own? The answer is not simple. The G-buffet does not make every underground facility vulnerable. Depth still matters. Geology matters. Construction quality matters. Target uncertainty matters. And the number of weapons available matters, but the psychological effect can be larger than the technical effect. The mountain no longer represents absolute protection. It represents time. And time can be valuable, but time can also be counted. That may be the most important strategic lesson. A fortress does not have to be invulnerable. It only has to remain dangerous enough to make the attacker hesitate. The mountain was therefore performing two missions at once. It protected the facility physically, and it protected it politically. Every additional layer of rock raised the potential cost of attacking. Every meter of depth increased uncertainty. Every unknown tunnel created another reason to wait. The mountain was buying time. But the attacker was also buying time, and that is the contradiction. Iran had time to build deeper. The United States had time to study deeper. One side used time to strengthen the fortress. The other used time to understand it. Eventually, those two strategies collided. The bomb was simply the moment when years of preparation became visible. The real operation had been happening long before the aircraft arrived. It happened in satellite imagery, in laboratories, in test ranges, in intelligence offices, in computer simulations, in maintenance hangars, and in the quiet calculations of political leaders deciding whether the risk of action had finally become smaller than the risk of waiting. That is what this story tells us about modern warfare. The most advanced weapon is rarely a single weapon. It is a network of people, machines, data, industry, money, energy, and political will. The buffet delivers the bomb, but intelligence decides where to aim it. Engineering decides whether it can penetrate. Logistics decides whether it can arrive. Politics decides whether it will be used. And geopolitics decides what happens afterward. That is the real weapon system, and it is also the real vulnerability. Because complex systems are powerful, but they are expensive. They require maintenance, they require coordination, and they can be disrupted. The same principle applies to the target. A nuclear program is powerful because it is a system. But systems have dependencies. They need electricity, scientists, materials, transportation, industrial equipment, financial resources, and political protection. The military objective may be to damage the facility. The strategic objective is to disrupt the system. That is a much bigger challenge, and it is why the story does not end with the mountain. It ends with the question of what the mountain teaches. For decades, military planners assumed that the answer to air superiority was simple. Go underground, but technology changes the calculation. Precision improves, sensors improve, intelligence improves, penetration technology improves, and the distance between hidden and known becomes smaller. Yet the opposite evolution is happening at the same time. Camouflage improves, deception improves, mobility improves, underground construction improves, dispersal improves. The defender is learning too. This is not a war between a bomb and a bunker. It is a permanent competition between concealment and detection, between depth and precision, between secrecy and surveillance, between the ability to hide and the ability to wait. And the consequences extend far beyond Iran. Because the same technology that allows one country to penetrate a hardened target changes how every other country thinks about its own vulnerabilities. Air bases, command centers, missile facilities, weapons factories, data centers, energy infrastructure. The lesson spreads. And once the lesson spreads, the next generation of defenses begins. That is how military technology evolves. One side creates a shield, the other creates a weapon. The shield improves. The weapon improves. And eventually, the battlefield moves somewhere else. The real question is no longer whether America possesses a bomb powerful enough to reach a mountain. The real question is whether destroying what is buried, beneath that mountain can actually change the strategic system above it. Because a country can lose a facility and preserve its knowledge. It can lose equipment and retain its engineers. It can lose time and become more determined. And it can lose a battle while changing the way it fights the next one. That is why the story of Fordo cannot be reduced to a crater. The crater is visible. The mountain may have been damaged. The nuclear infrastructure may have been disrupted. The timeline may have changed. But the deeper competition remains. And perhaps that is the most unsettling lesson of all. The future battlefield may belong neither to the side with the biggest bomb, nor to the side with the deepest bunker. It may belong to whoever understands the entire system first, who sees the supply chain before the weapon arrives, who identifies the dependency before the facility is built, who understands the political reaction before the first aircraft takes off, and who recognizes that every military advantage creates a new problem somewhere else. The question is no longer, who can destroy the strongest fortress? The real question is, what happens when every fortress learns that it can be found and every attacker learns that destroying it may not be enough? So what do you think? In the wars of the future, will victory belong to the side with the most powerful weapons or to the side that understands the invisible system behind the battlefield better than anyone else?